distillation and fractional distillation. So distillation is used to obtain a pure sample of a liquid. For example, if you wanted to get some pure water from some salty water. And fractional distillation is used to get a pure sample of a liquid from a mixture of two liquids. So if you had a mixture of water and ethanol and wanted to get pure ethanol, you would use fractional distillation. So this is a standard setup in which we have a round bottom flask, we have a condenser, we have a thermometer, and we have some kind of conical flask or beaker that we're going to use to collect the pure water that we're going to get. So what we do is we put water in the condenser. The water goes in the bottom, it goes around the outside of the condenser and then comes out the top. And we're going to use this to condense the steam that we're going to make, and it turns the steam from a gas into liquid water. And because of that, the water going in from the tap is cooler than the water that comes out. So in this flask, we have some salty water. So that's water with salt, sodium chloride dissolved in it. And what we're going to do is we're going to heat the salt water. As we heat the salt water, the water, which boils at 100 degrees C, turns from a liquid into a gas, goes into steam, and the steam rises, hits the thermometer, so the thermometer will read 100 degrees C. The steam then travels down there and hits the condenser. When it starts to go down the condenser, because the condenser is cold, the steam turns from a gas into a liquid, so it goes from steam into liquid water, and the liquid water travels down the condenser and then collects in this flask. So at the end, we'd be left with pure salt, because the salt doesn't boil, and we'd have collected all of the pure water over here. Fractional distillation, which is used to separate liquids which have different boiling points, is useful, for example, if you're trying to get pure ethanol from a mixture of water and ethanol. So imagine we've got some ethanol, or we've mixed it with some water. The ethanol molecules are red dots, the water molecules are blue dots. Now ethanol boils at 78 degrees C, water boils at 100 degrees C. So at 50 degrees C, for example, neither the ethanol nor the water will be gases, they'll still be liquids. But if you were to heat the water-ethanol mix to 78 degrees C, at 78 degrees C, ethanol goes from being a liquid into a gas, it boils. But at 78 degrees C, water doesn't boil. So at 78, if we heat the beaker up to 78 degrees C, the ethanol goes from being a liquid into a gas, and it would boil, and it would be leaving behind the pure water. So similar to simple distillation, in here we have a mixture of water and ethanol. If we heat it to between 78 and 99 degrees C, so it's above the boiling point of ethanol but below the boiling point of water, the ethanol will boil. It will go from being a liquid into a gas. It will go up there. It will hit the condenser. It will condense. It will go from being gas into a liquid. It will flow down the condenser. And then in here, we'll get pure ethanol.